That said, we are going to be talking about 100% visibility, how you can actually get visibility on the systems that you have and that you're running and that you're working on with people. And so in order to demonstrate this, I particularly love these. These are the ambiguous cylinders. So they're 3D printed objects that, depending on how you look at them, they can look like squares or like circles or like they're connected or they're separate. It's a really fun, interesting thing that you can print out if you have a 3D printer. But one of the things that it points out is that your perspectives actually matter. Your perspectives not only in what role you work in, whether you're a developer, whether you're an operations engineer, whether you're QA or management or security, but also your perspectives of your history, right? We often understand that the experience is what matters the most in our jobs, not necessarily what we learn in university or code camps, but seeing problems and understanding that we've seen this problem before or how this relates to things that have happened before. So that's what I'm going to be talking about, is a lot about our perspectives. Speaking of my perspective, so I'm Jason. I work as a technical evangelist, developer relations at a company called Datadog. I like to boil that down to saying that I do docs and talks. Docs meaning documentation, so I help write our technical documentation. I read through our source code to figure out what changes have been made and update our documentation based on that, or I talk to our engineers. And then the talking part. So I come to events like this. I share the best practices around monitoring, about how you build systems, regardless of whether or not you're using Datadog. So if you have challenges around monitoring, I would love to talk with you about that. Aside from that, I am a nomad. I live absolutely nowhere other than out of my suitcase. I do love whiskey, and if you see me wandering around Amsterdam, I'm probably not lost. I've been here enough that I know my way around, but I'm probably hunting for Pokemon. Yes, people still play that. A little bit about Datadog. Datadog is a SaaS-based monitoring platform. We do not only metrics, time series monitoring, but we do APM, or tracing, which I'll talk about a bit later. We also do logging. We handle trillions of data points a day, just to give you an idea of the scale. So in the time span that I've been talking, we've already ingested hundreds of millions of data points. We are hiring. So if you're looking for creative challenges, if you like to build tools for other engineers, take a look at jobs.datadoghq.com. And we are on Twitter as well, DatadogHQ, not Datadog. Datadog is actually a dog that has a Twitter account. So if you mix it up, that dog makes fun of you. I was also told that if you have questions, Slido, they're the people that are handling questions. So there's a nice website. Put in the hashtag Codemotion. You can submit your questions, and we'll answer those later. So back to the topic at hand. How are we getting our visibility? So traditionally, this is what our processes look like, right? You have some sort of development team. They write the software, and then you pass that to some sort of QA team, or maybe you're automating that, and you're running tests. And then that ends up on operations. They set up the servers, and they end up deploying it. And then somewhere way off at the end, there's monitoring. And this means that we're doing all of this observability type things at the very end. But it also leads us to things like this. This is actually Wikipedia's definition of DevOps. So they say that there's this realm of development, there's this realm of QA, there's this realm of operations, and this is a Venn diagram. So DevOps is the intersection of all of those. And this leads us to some very bad conclusions, because if you imagine that there are people in development and people in QA and people in operations, well, then clearly there should be people in DevOps, and this is why we say that maybe there's a DevOps engineer, that you can do this all with one person. And that's just not true. So if we're thinking about DevOps, I particularly like this definition. So these two gentlemen, Damon Edwards and John Willis, they were two of the founding members of the DevOps community, and they defined DevOps as culture, automation, metrics, and sharing. So what do they mean? Well, culture is the culture of collaboration and learning. The idea that DevOps is about learning and working together in order to build the business applications that we're hired to build. Our companies pay us not to set up Kubernetes or to write for loops and if statements. They pay us to actually build business applications. And then there's the automation. And this is, unfortunately, the thing that a lot of people focus on. They talk about DevOps being continuous integration or continuous deployment. But the automation really is there just to help us do our tasks faster and reduce the errors. The M in CAM stands for measurement, because you have to know how well you're doing in order to improve. So not only if we think about metrics or the information that we're gathering about our systems, but also about our processes. How are we as people actually working? What can we measure about our jobs? And then finally, the S stands for sharing. So spreading that information. Because again, this loops around to culture. If we're collaborating, then we're sharing that information so that all of us can get better at doing our jobs. So as mentioned, a lot of people think that this is DevOps. It's one person doing two roles. You know what? This isn't DevOps. This is overwork. This means your company just hired one person when they should have hired two, and now you're working too much. So this is not DevOps. What is DevOps, though? If we're thinking about getting visibility into our systems, then this is DevOps. It's not a Venn diagram. It's not overlapping circles. It's one big circle that's DevOps. And we have to think of this as developers and QA engineers and ops engineers having interesting, unique perspectives on our systems, right? Because your developers are writing the software, they have a different perspective than your operations engineers that are supporting it or deploying it to servers. So how can we get that? Well, the first is that we need to understand what we think of as the traditional stack. We talk about full stack engineers, which is great, but if we think of the stack, traditionally this is what we think of, right? You have infrastructure at the bottom, you have some sort of back-end services, some code that sits on top of that, and then you have front-end engineers that write the code that users interact with. And this leads us to having a lot of silos, right? Everybody's doing their own thing. Maybe their API is talking between each other, but the humans not so much. We need to rethink the stack as this. They're not separate pieces. They're different perspectives on the same thing. You're all working together to build that same business application. So if we think about visibility and how we should be monitoring things, about how we should look at things, well, then each of these is just a different perspective. So if we rotate our application and we look at it from, say, an infrastructure perspective, an ops perspective, what are we looking at? Well, the data that we're gathering is traditionally metrics and logs, right? Time series metrics and logs, we all know. The tools for this are traditionally going to be infrastructure monitoring. Tools like, well, Datadog, which I have to mention since I work for them, but maybe tools like, running things like Nagios, or running things like the tick stack, Telegraph, capacitor, things like that. And then you have log management. So again, I could say Datadog, but this could be the Elk stack, this could be Splunk, whatever helps you ingest those logs. But let's talk about the time series metrics. What do we think of? Well, they're value-based data. They're important. So when you have a metric, it's traditionally a thing. What is it? It's a value. How much is it? It's a time. When did it happen? And then increasingly more important, it's a tag. Where did this happen? What application was it in? What region was it in? Particularly as we start to spread our applications around the globe, different availability zones, different regions. But if we dive into metrics, metrics are useful because a single data point on its own is useless. But metrics, when we generate a lot of them, that's where we get our context. So we often combine them or aggregate them. If I were to say that a particular metric, for example, my CPU was at 80%, to illustrate this, that's not useful on its own. If I were to say right now, CPU is at 80%, is that good? Is that bad? We don't know until we actually look back at the history of it. So metrics are particularly useful not only when they're combined or aggregated, but they're useful for spotting those trends and patterns when we collect them over time, and we can start to analyze them. The other nice thing is metrics are very, very useful for sending alerts. Because they're small pieces of data, so we can receive them rapidly, so we get updates very quickly. In short, I like to say that metrics are useful for catching the known unknowns. So the known unknowns are things that you know about. They're things that you know are in your system, but you don't necessarily know at any given time what's going on. They're unknown. So that's why we call them the known unknowns. On the other side, logs are event-based, right? They're not a single point of data. Ideally, they're a lot of text. They're easy for humans to read, so you can use them to diagnose issues. You can actually read them as a person. You don't have to be a computer. But similarly, your logs should be well-structured. I highly recommend that no matter what you're using, converting your logs into JSON. You can easily do this because JSON is text. If you have a log line, simply add some curly brackets and some quotes around parameters. But that makes it very, very easy. It reduces the strain on computers, so you can ingest those really, really quickly. As mentioned, they're ideally verbose, so your logs, try to include as much information as you can. I know that makes them larger. I know that for some products, if they're charging you on storage like Splunk, that can get expensive. But if you're removing that data, it's going to be even more expensive when you go back and you need to use those logs to diagnose issues. So, as mentioned, they're useful for finding the details of a particular event. In short, this is what I like to say helps you catch the unknown unknowns. As with metrics, they're known things that you're monitoring. With logs, it's the things that you didn't know you had to watch for, and that's why logs are very, very important. Now, we take our application and we rotate it. We see the backend visibility. This, again, is similar. So this is going to be your backend developers. They're looking at, again, metrics and logs, but the new piece of information that we're going to be adding is traces. You absolutely need traces. And the tool that's involved with this is traditionally called APM, or Application Performance Monitoring, which is a horrible, horrible name because every single type of monitoring helps you understand your performance. But for better or worse, it's called APM. But if we look into traces, well, what is a trace? It's a request-based piece of data. So somebody makes a request on your system, and traces follow that request across all of the activity in your system. And so you get an idea of what function was called from another function, and where did that data actually go. And the good tracing systems are built for distributed applications. So you can follow that to your various microservices, and you can understand how your applications are talking to each other. So whereas metrics were good for your known unknowns and logs were good for your unknown unknowns, traces are particularly helpful for your where and your how long. Where did my application go? What code was called? And how long did that take? We'll rotate our application one more time. Take a look at front-end visibility. Again, the data here is going to traditionally be metrics, but our tools are very, very different. So we're talking about RUM, or real user monitoring, and synthetics. And if we dive into this, I like to think of RUM and synthetics as people and robots. They work best together. RUM actually analyzing and monitoring what real users are doing gives us good insight to how we can program our robots. And this is the same with anything if we think about robots in the real world. Nobody just builds a robot to do random things. They always think of what's the task that a human's trying to do, how can we replicate that? And the same thing happens with RUM and synthetics. The nice thing, then, is just like robots in the real world, whether they're cars, whether they're Roomba that's vacuuming your floor, they operate independently of users. So you can use those during the off hours when users aren't actually looking at your systems to get alerts. So I know I gave you all this data and talked about tools and monitoring, and it was all very boring. There's a guy back there who is falling asleep. It's OK, I understand. I had a beer during lunch as well. So let's give you an example. I haven't actually built this app, and my friends up front keep saying that I should, but let's use an example app of Datadog. It's Tinder for puppies. It's fantastic. We should build this. But this app is great. You get to have an app that shows you puppies, and you swipe right if you like the puppy. And it's amazing, right? If I built this app, you would all go out there and tell your friends to install it, and their friends would tell their friends, and it would be amazingly cute. I mean, that's amazing. But then it would get so popular, just like Pokemon Go, and it would crash because there's too many users, maybe. Some problem would happen. It's not a matter of if, it's a matter of when That's the way all systems are. So how do we debug something that goes wrong in our applications? How do we make use of the experiences and the perspectives of everybody that's involved in our various teams? Well, one way that we can actually know that things are going wrong is this. I mean, it's a valid way. That's how Pokemon Go knew that they were crashing all the time, was they just had a bunch of complaints on Twitter. But ideally, we want to know about these things before they're happening, or as soon as possible when they're happening. So let's take a look at these from various perspectives. How do we know if we actually have good monitoring from our front-end teams, good perspective from our front-end teams using real user monitoring? Well, we could use a tool like this. This is not Datadog. This is actually a company called SpeedCurve, which I think is a fantastic product. But they provide real user monitoring. And so with real user monitoring, you're actually monitoring how people are using your application. In this particular dashboard, we can see that 5% of people are actually scrolling, 2% of people are clicking around, 1% are doing a key interaction. That's a custom-defined metric. So that's things like swiping left or swiping right on a puppy. And then we could see that 91% are doing nothing. That's a problem. If we have users that have loaded up our application, that's particularly a problem if we see that our graph, there are more people using it as we trend to the right. We're getting more and more people interacting or not interacting with our page, but they're loading it. How do we know with synthetics? Well, the nice thing about synthetics, again, these are robots. We don't have to require users. But we can't actually measure if they're clicking on things. That's not useful. We've programmed them to click on things. We've programmed them to scroll. So how do we measure with synthetics? Well, we measure generally based on latency. How long did a particular application take to load? And in this case, again, this is SpeedCurve. They provide a film strip. So it's really nice to be able to see that this particular application on this load took about 30 seconds, and everybody received just a blank page for 25 of those. So you can imagine a scenario where maybe we have a third-party CDN. I particularly like Fastly as a CDN. They're the CDN behind GitHub and a bunch of other large sites. But let's say that we host our puppy photos on Fastly, and our application, as it should, pulls directly from the CDN because we don't want that traffic hitting our actual servers. Fastly, unfortunately, being very popular, also gets DDoSed a lot, particularly from China. Well, if we're using Raman synthetics, the great thing is that we can receive alerts on this, right? Because we're actually measuring how people are interacting with the application. And if they're not seeing puppies, well, then they're not swiping. So now we have metrics around that. But if we take a traditional perspective and say that maybe our developers or our operations engineers are responsible for this, so they're using APM or application or infrastructure monitoring, to them, all of our servers are up. We don't actually monitor Fastly because they're maintaining their own infrastructure. So we're going to miss out on that. So front-end perspective with run and synthetics, very important. Now, if we shift our perspective to our back-end engineers, well, how do we know if we're using something like tracing or APM? Traditionally, this is what our application should look like, a nice, smooth curve. So how do we know? Well, maybe our latency distribution looks like something like this, where suddenly there's a buildup. Half of our users are kind of slow, and then we see out at the 90th percentile, we see another little spike. So 10% of our users have a very bad experience. But with APM, one of the nice things, as I mentioned, is you can start to follow your code. You can understand what functions call other functions. So APMs provide us a nice view with what's called a flame graph. Flame graph, if I zoom in, it means that the first function that was called is that top bar, that span. And then we can see each subsequent function that was called. So if we're looking at this through APM, well, suddenly what used to take a short amount of time, we can easily see that now it takes a long time, that our spans get longer and longer. So what's a scenario look like? Well, if we have an application like Datadog and we have these puppy photos, everybody's uploading photos of their puppies. They may be gigantic 20 megapixel shots they took with their fancy SLR camera, or they could be like really cheap, crappy photos that they took with their mobile phone, right? So we want to resize all these images. So, of course, like many companies, we have an image resizing service. We pass our images. It maybe fires off a Lambda, resizes the image, and then sends that back to us. Well, what if the images are returned slowly? Right? With Raman synthetics, we may see alerts because the images aren't there, so people aren't swiping, but we don't actually know where. Right? We just know that users are having a bad experience. With application and infrastructure monitoring, the things that are on the back end, well, from our perspective, things are fine. That service is still up and running. Generally, things are OK. But the nice thing is that a problem like this of latency, of passing off to another service and then expecting things back, APM gives us that insight. So we can take a look at that latency and show not only that the service is bad, but we can follow those functions down and know exactly where in that service we should look. Let's rotate our application one more time. What does it look like from application monitoring? Well, you can imagine a scenario where a developer deploys bad code. Not that that ever happens, right? You all have amazing developers. Everything's automatically tested. But let's say that they happen to do that. And a developer deploys code that maybe improperly checks password hashes. So all users just can't log in. If we take a look at this from, again, the front-end side or the application developer side from APM, that is, everything's fine. There are no alerts, right? This might even pass our automated testing because, from the perspective of can a user with a bad password log in? Well, they're obviously denied, so we're totally secure. Everything's working as it should. Infrastructure monitoring, are our servers up and running? Well, of course they are. And again, everything's working as it should, right? Everybody just, for some reason today, they can't type their password. So this is why we really need application monitoring. We need to understand that when we're writing our code, we need to send those metrics, things like how many users are logging in at a particular time, and compare those to how many page views we're seeing. All of those important metrics that you want users to be doing, we need to write custom metrics in our code to emit those. It's very obvious when we do that when we send those to dashboards, when we send those to charts, if we see a drop, we can actually monitor for that. So let's take one more look at our infrastructure. How do we know when things are actually going wrong from an infrastructure perspective? Again, looking at dashboards, it should be pretty obvious. You should know what your resources are doing. But let's take that classic scenario. I mentioned Pokemon Go. We're just too popular. People love puppies. We're completely out of resources. How would we know? Well, with RUM, synthetics, APM, application monitoring, all of these will probably send you alerts because things just aren't working. But they won't help you identify why if you're too popular, if you're out of resources. Infrastructure monitoring, though, will. This is why you need to monitor your servers, to know how much CPU you have, how much memory you have, what's your network latency like. But more than just infrastructure monitoring, anomaly detection. If you don't have anomaly detection, whether that's algorithmic-based or whether that's machine learning, within your monitoring solutions, absolutely look into that. There are great open source projects. For example, Luminol, which is written by LinkedIn. There are also products. I'm not trying to be a shill, but Datadog has it built in. You don't have to buy us, though. But there are times when you have something like this, and you don't want to set that static threshold. You want that computer to look back at your history and understand when you should be seeing spikes, when you should be seeing drops, and alert you to those. So all of these tools will help you understand that something went wrong and be able to alert you quickly. How do you know what actually went wrong? Well, this is where the manual labeler comes in. You have to understand that there are different types of metrics. There are work metrics. Work metrics are the things that your business cares about. They're the things that you should get paged on to wake you up at night. These are things like users can't log in. Users can't swipe right on puppies. They're the things that are important. You take those and you look at the underlying resource metrics. Resources could be on the back end. Do I have enough CPU? Do I have enough network bandwidth? And then you take a look at those correlating events. Why did this happen? Our systems don't change for no reason. So that event could be a configuration change. It could be a new deploy, something that changed in our systems. And we can drill down from there. if no events happened on this level, that resource metric, for example, that our image resizing service went down, well, that becomes the work metric now for our image resizing service. That service team is responsible for that. They should get paged. And they can look at the resources that support that service. Did they have the servers that they need? Was the data store actually properly functioning? So a lot of people look at that and they're like, what are these levels? Well, I like to break them out as this. On the top level, you have the business level. This is where you get your technical leadership involved. They should be getting pages if your application isn't working. From there, you can take a look at the services that actually support that. Then you can start paging your service owners once you identify your service. Services are made of components. So if you have a team that's running various components, it might be a library. It could be a data store, for example, if you have a database team. And continue drilling down. The resources behind that are your servers, and that's when you get to your ops team. So this is how, when we talk about getting everybody involved in being on call and receiving pages, it's not that we want everybody to get woken up in the middle of the night. It's that each of us are responsible for a particular part or a particular level of our application. And once we do that, that's where the logs come in. As mentioned, logs are event-based. They should be detailed. They should help you understand what's going on within a system. So how do we actually get complete visibility? First, again, we have to think of our systems as a whole, not as different stacks, not as different silos. We're all working together for the same business application. We need to understand where we're at, what's our perspective, what's our part in that application, and understand that others are working on that and have different perspectives. And then we need to consider that we should have all the right tooling. Depending on what team you're on, you need that right monitoring tooling. If you're relying only on your ops team with using Nagios or using Datadog, using whatever they're doing to monitor, you're missing out. You're missing other perspectives, and you're going to miss failures. So that said, questions? As mentioned, it's on Slido. So, oh, and before we flip over to that, I will also do one more slide. Can we flip back? Sweet. So there's the slides in case anybody wants to download them. Publicly available. See a lot of mobile phones coming out. All right. Everyone got the photos? Going back to questions in 5, 4, 3, 2. All right. Let's go back to questions. What kind of performance testing tool would I recommend? How would I approach monitoring performance while running it? So there are a bunch of performance testing tools out there that will help you load test. It really depends on, again, what perspective we're looking at. So there are a lot of applications that will do essentially synthetics and launch a bunch of remote servers and hammer your website or your application. The load test really depends on what part you're looking at. So that said, I don't know that I have any particular recommendations. And then when it comes to my approach to monitoring performance while running it, definitely, like, if your system is unable to handle you adding extra requests to your system without crashing it, that's a bad thing. So adding actual performance monitoring or performance testing into your live application is important. But again, the tool is up to you. If that was you that submitted it and you want to talk later, come up and we can talk about your particular scenario. What practices help to identify the unknown unknowns? So the practice is that you really need to start with the known unknowns. So you need to start with that monitoring. And as mentioned, with that drill down, you start with the things that you are concerned about at your particular level of the application, whether that's at a high-level service level, whether that's more on the infrastructure side, anywhere in between. So use those metrics to understand what's going wrong in your systems. And then only from there, you need to understand what are the things that support my level of the application, and then what happened at that time. So if you have a good monitoring tool, you should be able to understand what time that happened at, right? So you received an alert at a particular time, or you looked at a dashboard and you saw a spike or a drop or something at a particular time, and you understand what application that is, and you take that information, and depending on your application, you might be able to easily transition into logs if it's the same product, or you can take that information and just look it up. What added value does Datadog have when using New Relic as well? So Datadog does, we have an integration with New Relic. So if you're using New Relic, it's very easy to import that information into Datadog, and that way you get your APM as well as your infrastructure and application monitoring in the same tool. What's the best way to learn how to use Datadog and all its features? Come talk to me later. We're actually building a training site. Let's see. If you would have to start somewhere, where would you begin? Oh, this is kind of general, but I'm assuming it means that if you have no monitoring at all and you're monitoring via Twitter that things are failing, and you need to buy that one monitoring service, what should you buy or what should you use? There's a lot of stuff out there. It, again, depends on what sort of tier you're at in the application. If you're a front-end person, I highly suggest that you don't buy Datadog, because that's going to be primarily application and infrastructure. That said, most people start with the application and infrastructure, because with application monitoring and being able to set custom metrics, it's the most flexible. You can have everybody in the organization generate custom metrics, simply adding a line of code to their application wherever they want to emit a custom metric. So that's a good place to start. And as I mentioned, like, if you're small and you're just starting out, there are plenty of amazing open source tools out there. InfluxDB is a great tool. Nagios, not so much, because it's pretty old. Sensu just released 2.0, so Sensu is a fantastic tool. I have friends that work there as well. Does Datadog have any machine learning powered features? So at this point, we don't do machine learning. We found that machine learning is tricky because you need to train machines. But we do have algorithmic-based anomaly and outlier detection. As with all the Datadog things, I try to shy away from being too salesy. So if you're interested, happy to give you a demo later, but don't want to eat up time selling a product, because I am not in sales. I'm an engineer. That said, any more questions? Cool. I've been told when you walk out of here, there will be people with iPads, and you should tap on them.